Hi everyone. Welcome to the chapter 2 of our today's discussion on scale from 0 to million users. So in the previous video we have described a basic architecture of how a request from to a particular website is being handled, be it the DNS or the web tier or the data tier and the load balancer. All these things we have discussed in our chapter 1. In this chapter we will be focusing more on reducing or significantly reducing the load or the response time of these requests, thereby increasing our throughput, decreasing the latency of the request being served to the end user. So without wasting any time, let's dive deep into these details of each individual components as you can see on the screen. So the first topic of today's discussion is cache. So what is a cache? So you might be aware of this term now. So cache is basically a temporary volatile storage that stores the results of expensive responses or frequently accessed data in memory so that subsequent requests can be served more quickly. So in general scenario, in the previous chapter what we saw that a particular request goes to a web tier, and from there if any data needs to be fetched, the request goes to the database server or the data tier. From there request is being served and to the web server, and the web server then performs the operation and sends back the response to the user. So what happens when we do one or more database calls to fetch the data, it greatly affects the runtime or the application performance actually. So in order to reduce this, or in order to mitigate this problem, what we do is we introduce a cache layer in between the web server and the database server. So if we write down what is a cache, so it is a volatile temporary, mostly in memory storage, and secondly it like what do we use for or what do we store in a cache. So we store the results of expensive responses and frequently accessed data. So like I mentioned, like this cache is a like the data tier or the web tier. This acts like an intermediary. It sits in between a web server and the database server. So if we look with the help of a diagram how this fits into our architecture, so like there is a web server and there is the data tier or the database, you can say. So in between lies our cache. So what is the role of the cache? So like suppose a response has arrived to the web server. So web server needs to make a database call or needs some data to perform that operation. So first it will go to the request first goes to the cache in order to fetch the data. So if the data is present in the cache, then the data is being returned to the web server. The web server performs the operation and sends back the response to the user. If in case the data is not present in the cache, so what happens? Now data is already present in the database, but it has not been updated into the cache yet. So what we do, we send the request to the database or we make a database call. Database in turn returns the result to the cache and also to the web server. So now the cache holds the data of the requested data which is being requested by the web server, and along with that the data is being also sent back to the web server to perform its operation. So this is the overall flow of how a data is being fetched from the database and moreover from a cache if the data is already present in the cache. So this is basically what I discussed. The flow is, this is also called a read through cache. So how do we interact with this cache servers? So basically most cache servers provide us APIs for common programming languages, and through APIs we can interact with this cache. So certain considerations, or we need to keep in mind certain things while we introduce this cache tier in between the web tier and the data tier. So like first we need to, so let's now discuss these considerations. So what are the considerations which we need to look into? So first we need to decide when to use cache. So if our system is like read heavy system, like data is being read frequently rather than being modified. So in that case, a cache would be a better thing which we can introduce to enhance our performance, to have a low latency system. So when to use, first thing which we can ask is when to use cache. So for that we will have, like, if it's a read heavy system, in that case a cache would be a better option to be introduced in our system architecture. So basically, actually cache stores volatile like we discussed. So a cache server is not ideal for persistent data storage. So for that, if cache server restarts, all the data in memory is lost. So for that case, we also need to consider these scenarios, so to introduce cache in our system architecture. Moreover, the cache should have an expiration policy. So what is meant by expiration policy? Like once the cache data is expired, it is removed from the cache. So like every data should have an expiration date, or else if the data is being already put into the cache and the cache memory is being exhausted, then newly fetched data or some data is being frequently fetched later, but it can't be cached because the cache memory is full. For that, what we do is we introduce an expiration policy for every data that is being put into the cache. So when there is no expiration policy, cache data will be stored in memory permanently, so that is not advisable. And also there should be a balance between the cache expiration date, like it shouldn't be too low, or else the data will have a cache miss every time. Like much frequently we will be having cache miss because the data will not be present in the cache. So for that, we should have a balance between the expiration date, like it shouldn't be too short or it shouldn't be too high. So this is one of the expiration policy which you can have. Third is, like, another important thing which you need to take care of also is called consistency. So like what might happen is, like, for a particular requested data, that data is being already present in cache, and we have performed a update operation on that particular data, which is being updated in the database but not has been updated yet in the cache. In that, basically in that single transaction, what has happened, like data modifying operations has been performed on the data store, but in cache the data has not been updated. So there is an inconsistency between the data which is being present in cache and which is being present in the data store. So we need to keep in mind while designing our system, like how we will be handling this inconsistency depending on our use cases. So the fourth thing, another consideration is, like, here we saw, like, we have a single cache, right? So what if this cache is down, right? If this cache is down, then there will always be a cache miss, and we have to every time go to the database to make a database call, fetch the data, and the database being served to the web server. So for that, this thing is called a single point of failure. So we have to reduce this. So like if single cache server is dedicated to our web server, which is serving the request made by the web server, then that is not a good architecture. So it is recommended to avoid single point of failure. So for that, what we can do is so this is the consideration is, like, mitigate single point of failure problems. So for this, what we can do is, first is, like, we can have distributed across various data centers, cache servers are distributed. Another recommended approach is, like, over provision the required memory by certain percentages. So this provides actually a buffer as the memory uses increases. So this is one of the consideration which we can have. Another is the eviction policy, or the algorithms through which whenever the cache server is full and if a new data has to be written into the cache, which data will be removing or which data will be replaced for this new data. For this, we have various algorithms like the LRU algorithm, which you might be aware of. This is a popular algorithm for cache eviction. Other popular algorithms which are also used is, like, the first in first out, or the least frequently used. All these algorithms can be implemented depending on our use case to evict the data and to enter the newly fetched data from the database or the data store. So this is the fundamental of cache tier, how it is being introduced in between the web tier and the data tier, what are the purpose of a cache, and some of the considerations which we need to keep in mind while designing depending on our use case, designing our system. So this is it about cache. So in the next section we will be discussing about another important feature, which is the CDN, or the content delivery network. So what is a CDN, or as the acronym goes, content delivery network. So CDN is basically geographically dispersed servers which are used to deliver static content. So these are geographically distributed servers, and what are they used for? Used to deliver static content. So what is this static content? Is like basically like HTML or CSS pages which do not change frequently basically for a particular website, or the images like the logo of a particular company and etc. The JavaScript files, all these can be delivered from this content delivery network for a particular website. So this basically helps a particular business to perform well. So like whenever we click on a link or whenever we visit a page, if that page takes a lot of time to load, then it is not good for a particular business, right? Because it's not a good user experience basically. So in that case CDN helps a lot. Like if we have a basic structure of a particular website, like if we see the logo of the company and certain basic static contents which generally do not get changed with time or do not get updated much frequently with time, then we have at least the user has a better impression, like that at least their web server is loading and certain contents are being fetched with time and they are being displayed to the user. So this is basically the main function of a content delivery network. So these are basically they are distributed across multiple geographical locations to provide the particular user who is nearby to the particular server. So like if a particular user is present in San Francisco and the CDN server is present in Los Angeles, another CDN server is present in Japan or Tokyo, let's say. So for a particular user who is in San Francisco, his request will be served by the CDN which is present in Los Angeles rather than the Tokyo. So this helps to improve the load time actually. So it helps to reduce the load time, or basically improves the load time. So like how this actually works, we can see through an example, like, and where does it fit in the system architecture. It's basically like so let's say a user through a web application is trying to fetch a website, like as we are seeing this example from the beginning, like facebook.com. So like whenever you open a facebook.com, the logo of the Facebook or the particular elements which are being displayed, like the home page and the news feed and the reels icon, etc., all these things are static, right? They do not change with time much frequently. So these things can be fetched from a CDN. So instead of going to a web server, the request goes to a CDN to fetch this static content. So if that static content are actually present in the CDN, then these contents are delivered to the user or the web application. If in case this content are not present in the CDN, then CDN in turn it gets the images from the server actually which hosts this website, and the images which are present or the static content which are present in this server in turn returns this static contents to the CDN, and CDN also caches this, I would not say cache, also stores this elements, these static contents for a certain period of time, so that it can be for the next user or for any other user whenever he or she requests or visits this website, then based on the location the nearest CDN server serves the static content to that particular user. So this is basically the flow. If 1 2 3 4, and if it's not present, this is 3 4 is basically visited if the static content is not present in the CDN. So basically user like tries to get certain image through an image URL. The URL's domain is provided by the CDN provider, let's say, and if the CDN server does not have the image in the cache, then CDN server requests a file from the origin, like this is the origin which server which stores the image actually. This may be a web server or online storage like Amazon S3, etc. This returns an image or the static content which the CDN server is requested for. Along with that, the request, it also sends a optional, like I mentioned, like optional HTTP header that is the TTL, the time to live, which describes how long the image will be cached. Time to live. The CDN caches this image and then returns it to the particular user who has requested this website, and user gets the image actually. So for this CDN, so I hope you understand like how CDN actually works, and for some of the considerations like we discussed in cache also, some of the considerations need to be taken care of for CDN as well. So CDNs are basically a third party service. So how is an user, or how is a particular hosted, like Facebook is charged, is like the amount of data which is being transferred from CDN to the particular user in that amount of bytes of data, as the rate is being charged per byte data. So the cost, we need to take care of the cost. These are third party users, so you are charged for the data transfers in and out of the CDN. So caching infrequently used assets provides no significant benefits. So second thing is like appropriate cache expiry, right? So we saw this header which is being sent from the server to the, along with the image, static content to the CDN, appropriate cache expiry. So like for time sensitive content, we can set a cache expiry which shouldn't be too short or shouldn't be too long, as we saw in case of also cache, like the expiration, if you remember, we discussed in cache this expiration policy. So third thing which we need to keep in mind also is the CDN fallback. So like if there is a temporary CDN outage, so clients should be able to detect the problem and request resources from the origin. So it shouldn't be the case like if the CDN is down, the entire system is down, or the entire server is down. In that case, the client should be able to detect the problem and they request the image or the static content from the original server which is hosting these things. And another important thing is like invalidating files. So like suppose some certain static content, we are changing actually the static contents, so we can mark them as invalidated, like using APIs provided by the CPN vendors, using APIs by CDN vendors, and we can also attach a certain version along with the parameter to the URL, like a version number, so in order to detect which is the latest version to be fetched from the CDN. So these are some of the considerations which we need to take care of for CDNs. So CDNs are basically a content delivery network, geographically distributed, and is to deliver static contents. So now we have discussed about cache and CDNs. So let's look into a diagram which describes how these two components actually fit in our system architecture, which we have discussed earlier also. So as you can see from this diagram, so how CDN, where is CDN is located, where is the cache located. So CDN is used to deliver static contents like the JavaScript or CSS or images, which are now not being served by the web servers. They are fetched from the CDN for better performance. And we have the database load being lightened by introducing a cache in between the web server and the data tier to fetch the expensive responses or the frequently accessed data. So now, considering the topics which we would be looking into in today's lecture, let's move on to the next section, which is basically our stateless web tier. So now let's discuss about stateless web tier. So before that, let's discuss what is a stateful architecture. So by the name, as you might have guessed also, so like it is denoting some kind of state. So what is a state? Basically this is a client data kind of thing which a server actually stores in its cache or in its memory to authenticate the user or to fulfill the request of a particular user. So let's understand this with the help of a diagram. So this would make the understanding more clear. So here, as you can see, for server 1, user A's session data and the profile image. So what do you mean by session data is like it's a login information or the user A's sign in information, or suppose it's an e-commerce website, like he has put some things in the cart and after that he has logged out and he is trying to again log in from that state. So whenever he logs in again, he will see that those things are already present in his cart. So these are the sessions data of a particular user along with their profile image is being stored in the memory of a particular server. So in this case, so whenever user A tries to log in into a particular service or a particular website, then the HTTP request is already redirected to the server 1 to authenticate that particular user. So if in case the request is, so if the request for user A goes to server 1, then he or she is being authenticated and he can access the website. If the in case the request goes to, let's say, server 2 or server 3, then server 2 or server 3 does not have information about user A, right? So he or she can't be authenticated by the web server, and thereby there would be a denial request to log in into that server or to access that web server or the service. So this is accessible, whereas these two are not accessible. The issue is that every request from the same client must be routed to the same server. So this can be done with the sticky sessions of load balancer. So you can read more about it. I'll post link in the description. So how do we attach a sticky session? So in some scenarios we need stateful architecture for certain use cases. So for that case, how sticky sessions are being attached to the request, it being sent to the load balancer. Load balancer stores those sticky sessions, and the sticky session is being sent to the user. So whenever user now connects with the load balancer, the sticky session is also being attached in the header. The sticky session being matched with the load balancer, the load balancer now knows how which user is being trying to connect now. So particular with that sticky session, the load balancer redirects the request to the particular server. So this way a sticky session works. I discussed in a high level, so you can read more about it. So but however, there are certain problems in this architecture, right? So like every time if the user server 1 is down, let's say, then user A or certain particular users can't log into the or can't access the service. Or let's say adding or removing servers depending on the server load would not be a feasible option in this case, right? So this acts like an overhead for all this performance. So for that, what we do is we introduce a stateless architecture. So by now you have an idea what is the stateless architecture. Basically, stateless architecture is a certain kind of architecture in which the session data or the profile image or any data pertaining to any particular user are not being stored into the server. Rather, a separate data store is being used to store the client data to authenticate the user or to perform certain operations. So in stateless architecture, actually HTTP request from user can be sent to any servers, web servers, right? So which fetch state data from a shared data store, and state data is stored in a shared data store and kept out of web servers. So it looks like something like, let's say you have user A, user B and user C both trying to connect, and there is this web server here. So all of them can connect to a single web server. This web server in turn connects to a data store, let's say, which stores the shared data of each client. So this is a shared storage which fulfills the user's request or authenticates the user and then lets the user to actually access the service. So this stateless system is actually more scalable and robust. Moreover, this web tier is now completely independent of any client data. Like web tier is independent now. So it doesn't depend on any client data, and any request needs to be redirected to a particular web server only. All these things are now gone. So in this way, this stateless architecture helps in multiple ways. So now let's look into our focus or what is this shared storage type. So this is kind of like we need a database, right, to store the session data of a particular user. So this could be a relational database like Memcached, Redis, or like NoSQL, etc. Actually, NoSQL is basically preferred. This is preferred by because this is easy to scale, as we have seen in the SQL versus NoSQL comparison in chapter 1. So this is easier to scale. So after the state data is removed out of the web servers, auto scaling of the web tier is also now can be performed very easily. They are reducing load on particular web servers, and we can introduce more web servers depending on the load. and thereby redirecting the traffic to multiple web servers. So this is basically the overall advantage of using a stateless architecture, but depending on certain use cases, stateful architecture is also being used. So now what happens is like, from, let's say, initially facebook.com was popular in USA. Now with time this facebook.com is being popular in across every continent right now, right? And people are now trying to access this facebook.com from multiple geographical locations. But however, if that servers are only concentrated in particular location, like say USA, then for a particular user who is in Asia, he or she might have a load or the response time much higher compared to an user who will be present in USA, and that is not a good thing for a particular business to operate, right? To improve this availability and provide a better user experience across wider geographical areas, we now have multiple data centers. We need to have multiple data centers. So our next topic is like data centers. So now we'll be looking into data centers with the help of a diagram. So here you can see there are two data centers which are being introduced currently. Let's say one is US East, one is US West. So, and in normal operations, users are now geo-DNS routed. Like, what is geo-DNS routing? So like they are being routed depending on the geographical location to the closest data center, with a split of traffic. Let's say X percentage of users go to the US East and the 100 minus X percentage of users go to US West. So geo-DNS routing is being supported in this case. So what is geo-DNS routing? So like it's a DNS service that allows domain names to be resolved to IP addresses based on location of user. So DNS service, domain names resolved to IP addresses based on geographical location of user, right? So if in case there is a significant data center outage, and all this data is being replicated in multiple data centers, as we have seen in case of cache, right? So in order to have avoid single point of failure, in order to make data easily available or fast available for a particular user depending on geographical location, we replicate this cache, database, data tier, etc. in multiple data centers. So in the case of any significant data center outage, we direct all traffic to, let's say, a healthy data center. So we need to take care of multiple technical challenges while setting up multiple data centers. Like one is traffic redirection. So effective tools are needed. So some of the considerations which we need to take care of in setting up multiple data centers is like, one is traffic redirection. So what is this? What does this tell? Is like effective tools are needed to redirect traffic to correct data centers. Like for this we use geo-DNS tooling, geo-DNS routing, etc. to redirect a particular user to the nearest data center. Second thing which I also mentioned just now is like data synchronization. For this you can read or go through the playlist of key value store where we have discussed about how data is being synchronized across multiple data server nodes. So data synchronization is very much essential. Like a particular user who is closer to US West will be using this database, another user will be using this database, like, but they are trying to fetch the same data, or like they are trying to gather information of same data. So this data should be consistent across both the locations, and in case of failover, the traffic might be routed to a data center where the data is available. And we also need to test and deploy the multiple data center setup. So this is important for proper running of our website or an application. So this is like test and deployment of data centers. So these are some of the considerations which we need to take care of while we are setting up multi data center setup. So to further scale our system, what we can also do is like we can decouple different components of the system so they can be scaled independently. One decoupling which we saw is like in the stateful architecture, right? We decouple our web server from the session data or the client data. Thereby we can independently scale the web tier, we can independently scale the shared storage. Similarly, another thing we can discuss about like decoupling of our web servers from the request which we receive, and the processing of the request is through a message queue. So the next topic which we will be discussing is message queue. So message queue is a key strategy employed by many real-world distributed systems to solve this problem of decoupling to scale independently each of the services, although being connected to each other but in an independent way. So for what is the scenario in which we use a message queue is like, consider a web server which is handling a large number of requests, right? And it has a certain limit capacity. It might be the case like its buffer is full to handle the request, and new requests are being coming but they are being dropped, and there is a significant drop in the number of requests which is being rejected for a particular web server because its capacity or its buffer is full. But in ideal scenario, what do we want? A web server to be have a high throughput, low latency, right? So in that case, so these are requests incoming, but web server has a high drop due to buffer is full. So for that case, what we do is we introduce something in between. What we introduce something in between is a message queue. So what is the role of a message queue? So in message queue, let's say the requests which are being coming, and the processing of request by the web server, these two things are now independent. How they are independent? So before moving into the discussion of how they have now become independent, so let's introduce two terms like this request incoming or the request which is being produced. These are called producers who produce the request, or these are the end users who actually tries to log into a particular website or trying to access a service, and the web server which is being processing these requests, these are called consumers actually. So in between we have a message queue. So let's say requests 1, request 5, etc. are present here, request 2, sorry, and web server, what in turn, whenever its processing has been done and let's say its buffer is full, it is continuing its process. In the meantime, the producers are producing the requests and they're filling up the message queues. So once the web server is free, it checks whether there is any pending tasks to be done from the message queue, takes this task and processes the request. So consumers basically subscribe to the message queue, producers produce the message and put it into the message queue. So in this way, decoupling makes the message queue a preferred architecture for building a scalable and reliable application. So I hope you understand what is how does the message queue works and how this decoupling has helped us in serving the request without the web server being unresponsive or the web service being down or failed to connect being shown to the particular end user. Another thing which we can discuss for like large scalable systems, logging or metrics, like the system is being used now by across various multiple geographical locations, and our scale system is like a robust system right now. So when working with a small website, these things are not much taken care of, but whenever our system is like a large business, we need to invest in these tools to for a better performance, for better end user experience. So logging is like monitor. So logging is used to monitor and error logs actually to help identify errors and problems in the system. So in metrics, what we can have is like we have the CPU or the memory which is being currently in use. If there is a CPU, if there is a memory exhaustion or disk input output, this metric we can track. We can also track aggregated level metrics. What is aggregated level metrics? Like the performance of the database tier, cache tier, etc. And we can also store key business metric for better business insights like the daily active users, the retention, etc. all these things we can store. And moreover, we can have a automation like setup like the continuous integration, continuous deployment setup to test our application, so that before it being produced to the end user, we can test our application, test our module every time, so that there is no problem to the end user when they are using. So all these things which we can do for a particular large business, we can invest in these tools. So with these discussions, what we have discussed so far, we have scaled independently. Let's look into the entire diagram of how these things are incorporated into the final system architecture. So here you can see this is the final system architecture of all the components which we have discussed in chapter 1 and chapter 2. So if we focus on the things which we discussed here, first is like the cache. This is the first thing which we discussed, which is being present between the web tier and the data tier. Then we have CDN to deliver static contents to the user, so that before moving the request to the web server, static contents like the images, the HTML pages, etc. are being delivered to the end user. Then we have shared data storage to store the session data of a particular client. By that we made the web tier independent of any session data or client data and can be scaled independently. Fourth, we discussed about these message queues, which decouple the incoming requests to the processing of request by the web server and the incoming request from the end user. We have discussed about message queue, which helps to build us a distributed and a scalable system. And fifth, we also discussed about this logging and the metrics. Whenever our user base has increased a lot or the business is now a large scale business, we can invest in these tools to log the error logs to check where the system has gone wrong, or why we can invest in metrics also to store the key business metrics to get an information of how many monthly active users, daily active users, retentions, etc. And monitoring and automation, all these things can be done to test and deploy our application. So this is an overall architecture of how we can scale from 0 users to million users. So I hope you have gone through both the chapter 1 and chapter 2 and have got an idea how we scale from 0 users to million users and support million users with this kind of architecture, with this kind of components, thereby significantly also reducing the load and the response time by optimizations also, like introducing the cache, introducing message queues, introducing shared data storage, CDNs, etc., which significantly reduces our load or the response time and also increases the throughput of the web servers. So in the next section, in the next video, we have in this video we have discussed till about how we are already scaling the web tier, right? We are making it independent of the shared data storage. Now we can scale the web tier depending on the traffic load. In the next video, in the next section, we will be discussing about how we can scale the database tier or the data tier, like vertical scaling, horizontal scaling, which we have discussed earlier in chapter 1. We will be now looking into that thing for data tier. We will be discussing about sharding and how the data is being distributed in multiple shards, etc. So thank you for watching this video, and I hope I see you in the next video.